Okay, this is the first free response question. I should note I'm not gonna go through the entire energy packet yet. I know that the progress check due date is on tomorrow for B day, which is what I'm doing this now. Um, so I'm gonna do first 4 pages of energy and the first 4 pages of impulse slash work or whatever. Um, and then after that, maybe I'll do the rest. But this is just like for this first progress check, so everyone like knows what to do. So I think I have like what 2 more FRQ after this. I have the arrow question. Yeah, I have the arrow one. I didn't do the other two yet. I didn't do question 3. I didn't do part A. I gotta do that. But I do have impulse ready to go, so I'll just do that after this. Anyways, this question is actually very simple. I totally overthought this the first time I did it. I mean, like, I have so much work on my page that's just so freaking irrelevant. Anyways, the easy way of doing this that's not so unnecessarily overcomplicated is where's my okay. So, all that really matters from here is that they're all released from 2 meters and there's no air resistance. So that means this 2, this is 2, this is 2, and this would be 2. If there's no air resistance, then this is just gonna fall at like mgh, right? So whatever the mass is of this times the height, whatever. C and D will be falling at the what is it? Like same exact speed, the same amount of energy. Because if this is frictionless, this going down here and this going down here is basically the same thing. Um, again, because it's frictionless, right? It's the same height. So ultimately, for these 2 blocks, it'll be whatever the mass is times 10 for gravity times the height, which is 2 for both of them, which is going to get you the same freaking thing, right? So the energy that these blocks have are going to be the exact same, no matter what. So that ends up being what? Those are going to be your greatest. So it's going to be C is equal to D, for 3 and 4. A and B is where it's different because these actually do give you what is it, coefficients, or what is the kinetic coefficients. And then so for this one it's going to be actually B and then D. So B will have the least amount of kinetic energy at the instant. So that's like instant over hits the ground is going to be like right here. Like right here, how much energy does it have? These two are going to have the most because there's nothing going against, there's no friction pulling it back, right? There's no air resistance pulling it back. But for these two on the ramp, they do have friction. Since this is traveling the most amount, like obviously like this is a much longer distance than this will be more affected by the friction. So by the time it gets down here, it's going to have a lot less energy than A will over here, which is why B is less than A, and then A is less than C, which is equal to D. Um, that's it. That's really it. Initially I was doing like the whole conservation of energy thing. W is equal to EF minus the initial. I did it just for A. And then so much work came out of that. I mean, I was like solving for Fn so I can get the coefficient of friction, um, and like get the friction necessary. Once I got to B, I was like, yo, I'm not doing this. But yeah, this is the easy way. So again, C is equal to D because since this is frictionless, this is the exact same as if it were to just fall down normally. There's no force preventing it from falling and therefore taking away from its kinetic energy. So these two will be the same. And then since this is a longer distance than this, the amount of energy lost via friction will more heavily impact B than it will A. So yeah, that's it.